Hello, my dear students. Statement 1. The freezing point of 0.1 molar aqueous solution of urea. Urea NH2CONH2. Urea dissociation. Urea want half factor value. The want half factor value of urea I is equals to 1. NaCl. Sodium chloride dissociate like Na plus Cl minus. So want half factor value is equals to 2. Number of solute particles are increases, then freezing point value is decreases. Number of solute particles inversely proportional to freezing point. So urea freezing point is greater than NaCl freezing point. Based on that first statement wrong. Second statement, NaCl is an electrolyte and aqueous solution contains more number of particles. Correct. Compared with urea, it contains more number of particles. Statement 1 incorrect, but statement 2 is correct. Liquid P and Q form an ideal solution at 300 kelvins. The vapor pressure of pure P and Q are 200 pascals and 500 pascals respectively. The composition of P in vapors which is in equilibrium with a solution containing 50 mole percent of P at the same temperature. 50 mole percent means mole fraction of P is taken as 0.5 and mole fraction of Q is also 0.5. By using given data, calculate the partial pressure of P. Partial pressure of P is equals to total pressure into mole fraction of P. According to Dalton's law, partial pressure is equals to total pressure into mole fraction. Now, according to Raoult's law, partial pressure of P is equals to mole fraction of P into P naught initial. Simplify now. This is pure, that's the reason P naught you can take. Mole fraction is 0.5 into 200, that is equals to 100. Partial pressure of Q is equals to mole fraction of Q into P naught Q. This is P naught P, P naught Q. Now simplify. 0.5 into 500, that is equals to 250. Now total pressure P total is equals to 100 plus 250, that is equals to 350 pascals. Now in vapor phase, according to Dalton's law, partial pressure is equals to total pressure into mole fraction. Now calculate mole fraction of P is equals to partial pressure of P by total pressure. Partial pressure of P 100, total pressure 350. Simplify, then you will get 0.2857. Mole fraction of P is equals to 0.2857. But here percentage is the question. Mole percent of P. Mole percent of P is equals to 0.2857 into 100. That is equals to 28.57%. First option correct. The limiting molar conductance of KBr, KCl, NaCl are 150 to 150, 126 Simon centimeter square mole inverse respectively. Then lambda naught of NaBr will be. Now apply Kohlrausch law. According to Kohlrausch law, lambda naught NaBr is equals to sodium ions are present in NaCl, bromide ions are present in KBr. So add these two, lambda naught NaCl plus lambda naught KBr minus lambda naught KCl. Lambda naught NaCl 126 plus 152 minus 150. You will get 128 Simon centimeter square mole inverse. Second option correct. What will be the EMF of given cell? Cell is given. Two parallel lines represent salt bridge. Salt bridge left side equation is anode equation. Salt bridge right side equation is considered as cathode equation. At anode, oxidation takes place. Anode oxidation takes place. Half H2. H2 is the gas. P1 gives rise to H plus aqueous C1 plus 1 electron. At cathode, reduction takes place. H plus aqueous C2 plus 1 electron gives rise to half H2 gas P2. Add these two equations. Then overall cell reaction. Overall cell reaction is 1 electron get cancelled, but half H2 P1 concentration, but here half H2 P2 concentration. So half H2 P1 plus H plus C2 gives rise to H plus C1 plus half H2 P2. Now what will be the EMF of given cell? EMF is calculated by using Nernst equation. E is equals to E naught minus RT by NF ln C or ln Q, whatever it may be, or ln K. If the reaction is in equilibrium, ln K you can take ln K. K equilibrium constant, ppc by prc formula. We know that for hydrogen electrode, E naught cell value is equals to 0.00 volts, N value is equals to 1. Then E is equals to minus RT by F ln product concentration by reactants concentration, ppc by prc. So C1 into P2, how many moles? 1 by 2 moles. P2 whole power 1 by 2 whole divides with C2 P1 whole power 1 by 2. Here options are given in terms of positive, or it can be also written as RT by F ln C2 P1 whole power 1 by 2 divides with C1 P2 whole power 1 by 2. Now check it. No. Now do one thing. Or this is also written as RT by F ln squaring. You can do square, then C2 square P1 power 1 by 2 whole square is nothing but P1 by C1 square P2. You can check it, C2 square P1, C1 square P2. So power 2 divides with 2 also. So now you can check it, RT by 2F ln C2 square P1. Second option. How 2 is obtained? Here square root, nothing but is how 2 is obtained. RT by F ln C2 P1 whole power 1 by 2 C1 P2 power 1 by 2, or it can be written as RT by F ln C2 square P1 by C1 square P2 whole power 1 by 2. Check it right or wrong. This is also written as C2 square whole power 1 by 2 P1 whole power 1 by 2. That means square root of C2 square root of P1, square root to cancel, then C2 square root of P1 is also written as P1 whole power 1 by 2. Now this is look like log of a power m. Log a power m formula is m log a. So RT by F m log a 1 by 2 ln C2 square P1 C1 square P2, or it can be written as RT by 2F ln C2 square P1 by C1 square P2. Match the following: 1 mole of Cr2O7 minus converted to Cr3 plus. Calculate oxidation state X is equals to plus 6, X is equals to plus 3, oxidation number difference is 3, N factor value. What is the N factor? 2 chromium atoms are there, 3 into 2, 6. N factor value is equals to 6. It requires 6 Faradays of current. 6 into 96500. 6 into 96500 is 579,000 coulombs. P2. Next, 1 mole of 2 moles of Pb plus 4 is converted to Pb2 plus. Pb plus 4 is converted to Pb2 plus. Change in oxidation state plus 4 plus 2. Oxidation number difference is 2. N factor value 2 into 1 is equals to 2. This is for 1 mole. 1 mole N factor value is equals to 2. But here how many number of moles? 2 moles. For 2 moles N factor value is equals to 4. It requires 4 Faradays of current. So 4 into 96500. 4 into 96500 is equals to 386,000 coulombs. P2Q3. P2Q3. First option correct. In a gas phase reaction, X gives rise to Y plus 2Z. The increase in pressure from 100 mm of Hg to 120 mm of Hg is noticed in 5 minutes. If the decomposition of X follows first order kinetics, then what is the rate of decomposition of X at 10th minute? First of all, rate is equals to what we know. It is a first order reaction. Rate is equals to K into concentration of the reactant. Rate is equals to K into concentration of the reactant. Given, apply integrated rate equation of first order reaction. First calculate the value of K. K is equals to 2.303 by T log of R naught by R. Here given the equation is X gives rise to Y plus 2Z. X gives rise to Y plus 2Z. At time t is equals to 0, pressure is equals to P naught, reactants having some concentration, product concentration is 0. If time is going on, time is equals to 5 minutes. If time is equals to 5 minutes, then P naught minus X, here 2 moles of Z, that's the reason 2X. So P total is equals to P naught minus X plus 2X. Minus X plus X cancel. P total is equals to 2X. Here P total is given as 120 mm of Hg. P total is equals to P naught plus 2X. P total value 120. Initial value, what is the initial value? P naught value is taken as 100 plus 2X. Then X is equals to 10 mm of Hg. Now substitute here. Initial concentration is 100. Then at time t is equals to 5, P naught minus X, 100 minus X 90. So K is equals to 2.303 by 5 log of initial concentration is 100, final concentration is P naught minus X, 100 minus 10 is equals to 90. So simplify, then you will get the value of K is equals to 0.02107 minute inverse. This is at time t is equals to 5 minutes, but question is at 10th minute. So K value we know. Those are the same chemical reaction at 10th minute. Now again take the integrated rate equation. K is equals to 2.303 by T log of R naught by R. K value already know. What is the K value? 0.02107 is equals to 2.303 by time 10th minute log of R naught value fixed 100 at 10th minute. How much we don't know. Calculate final concentration at 10th minute. So it can be written as 0.02107 into 10 by 2.303 is equals to log A by B formula, log A minus log B. Simplify now. Then log r is equals to log 100 is log 10 square. Log 10 square is also written as 2 log 10. 2 log 10 value is 2 minus, simplify this value, you will get 0.0915. Then log r is equals to 2 minus, sorry, then log r is equals to 1.9085. R is equals to anti-log of 1.9085. Decimal before number is 1, 10 power 1. Remaining 0.9085. Log 10 value 1. Log 8 value. Log 8 value is 0. Calculate log 8 value. Log 8 is also written as log 2 cube 3 log 2 3 into 0.3010 0 3 0 9 0.9030. Here 0.9085 is there after removal of 1, because 1 is already written in terms of scientific notation. So log 8 value is exactly this much, but this value is more than this. So you can take 8.1 or 8.2. 8.1 into 10 power 1. Then the concentration of R is equals to 81. Now rate, calculate the rate. What is the value of K? K value is 0.02107 into reactant concentration at 10th minute is 81. Simplify, you will get 1.695. First option correct. Statement 1, with increase in temperature, rate of reaction increases. Correct. How? On increasing the temperature, molecules gain more kinetic energy. That's the reason rate of reaction increases. Statement 2, increasing the temperature of reaction, increase the fraction of molecule which collide with energy greater than threshold energy. This is also correct according to Maxwell-Boltzmann. So both the statements are correct. Choose the correct statement. NH3 is less basic than pH3. Wrong. NH3 is more basic than pH3. The correct order of boiling point of hydrides: NH3 greater than SbH3 greater than AsH3 greater than pH3. Correct. Because NH3 boiling point abnormally increases due to H bond. Remaining options are also wrong. How many statements given below are correct? Chlorine has highest electron affinity. No doubt. Chlorine electron affinity is more. Fluorine oxidizes water to oxygen. This is also correct. 2 moles of F2 plus 2 moles of H2O gives rise to 4 moles of HF plus O2. Concentrated H2SO4 cannot be used to prepare HBr from KBr. This is also correct. Because H2SO4 is a strong oxidizing agent. That's the reason we can't use. Is a strong oxidizing agent. XeF6 reacts with RBF to form Rb plus XeF7 minus. This is also correct. SO3 contains only one p pi d pi bond. Wrong. SO3 you can consider. In SO3, total number of pi bonds, 3 pi bonds. In this, one is p pi, and the remaining pi bonds are 2 pi bonds are p pi d pi. So 1, 2, 3, 4 statements are correct. Which of the following transition element does not show variable oxidation state? Scandium. Scandium does not show variable oxidation states. Scandium exhibits only one oxidation state, that is scandium plus 3. Assertion KMnO4 is purple in color. Correct. KMnO4 is purple in color. The purple color of KMnO4 is due to DD electron transition. Wrong. A true or false. KMnO4 is colored due to charge transfer phenomenon. Due to charge transfer phenomenon. The charge transfer phenomenon is LMCT, ligand to metal, charge transferred. Which of the following has lowest CO bond order? Calculate the oxidation states. CrCO taken 6 times. Carbonyl CO group. Carbonyl group is the neutral group. So here oxidation state of chromium is equals to 0. Oxidation state of manganese is equals to +1. Oxidation state of vanadium is equals to -1. Oxidation state of iron is equals to 0. Question is related to lowest CO bond order. The CO bond order is directly proportional to oxidation state of central atom. Oxidation state of central atom. So based on that, third option correct. Why it depends upon oxidation state of central atom? Because it is all these are metal carbonyl compounds. Metal carbonyl compounds. In metal carbonyl compounds, synergic bonding is involved. Synergic bond is also called as back bond. Choose the correct statements among the following. The oxidation state of nickel in NEET-JEE taken twice is 0. Wrong. First, DMG. What is DMG? Dimethyl glyoximate. It is a negative ligand. DMG -1. So oxidation state of this compound is not 0. Oxidation state of this compound is +2. Next, Na2EDTA is used to remove Ca2 plus and Mg2 plus ions from hot water. This is correct. Vitamin B12 contains CO3 plus. Correct. Cisplatin is used in cancer treatment. Correct. So B, C, D are correct answers. B, C, D. You can change this option. B, C, D. Third option correct. The set of second group basic radicals whose yellow precipitate are soluble in yellow ammonium sulfide. Second group basic radicals. Second group basic radicals are again divided into group 2A and group 2B. Group 2A. Group 2A Hg2 plus, Pb2 plus, Bi3 plus, Cu2 plus, Cd2 plus. 2B. 2B is arsenic, antimony, SN2 plus, even SN4 plus. Question is, whose yellow precipitate are soluble in yellow ammonium sulfide? Yellow precipitate is soluble in yellow ammonium sulfide. Remember here HGS, PBS, CUS, black PPT, Bi2S3, brown black, cadmium sulfide, again yellow PPT. So cadmium is yellow PPT. AS2S3, SnS2, yellow PPTs. Based on this, third option correct. Remaining SB2S3, orange PPT, SNS, brown precipitate. Once revise, radical stable. Statement 1, acetaldehyde, CH3CHO, aliphatic aldehyde gives positive Fahrenheit test. Correct. Positive Fahrenheit test, positive tolerance test, positive 2,4 due to presence of carbonyl group, even gives iodoform test because due to presence of CH3 C double bond O, positive iodoform test. This is also correct. Statement 1 correct. All aldehydes respond, all 4 tests mentioned. Wrong. For example, you can consider benzaldehyde. Benzaldehyde, it does not give Fahrenheit test, it gives Tollens reagent test. So statement 1 correct, statement 2 incorrect. In the following reaction, the major product is generally here carbonyl groups are involved. Carbonyl group. We know that carbonyl groups are participate towards nucleophilic addition reactions. Nucleophilic addition reaction. See here, what is the major product? The major product is first one. This is the major product. How this is the major product? Because the central carbonyl group C double bond O, I am talking about this carbonyl, is highly electrophilic, not nucleophilic. Highly electrophilic because it is present between two other carbonyl groups. That's the reason here chemical reaction does not take place. No H2O dissociate H plus OH minus. Break the bond oxygen negative carbon positive. Oxygen negative carbon positive. So what is formed? C OH OH. So C OH OH. You can add not first option. Chemical reaction. So then you will get COH OH COH OH C double bond O. Two OH groups on same carbon atom. Gem diol, highly unstable. It loses water molecule again. Remove the water molecule OH H2O OH H2O. Again what is formed? Again it gives C double bond O C double bond O C double bond O. Okay. Now this is electrophilic group, highly electrophilic. Highly electrophilic. Now add H2O here. Add H2O here. Break the pi bond and add H2O. H plus OH minus. Then it gives the compound like this: C double bond O, C double bond O, C, H, C, OH, OH. This is electrophilic reaction. So answer is third option. What is the major product in the following reaction? Benzene reacts with SL halide. This is Friedel-Crafts reaction. Friedel-Crafts reaction RCOCl CH3 C CH3 CH3 COCl in the presence of Lewis acid. Then in the presence of Lewis acid, it generates the electrophile. The electrophile is CH3 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 CO plus. CO plus. Here this carbon atom is which carbon atom? 3-degree carbon atom. This is the carbonyl group. This is the 3-degree. How many alkyl groups are attached? 3 alkyl groups are attached. So formed reaction intermediate CH3 taken thrice CCO plus. This is also called as pivalyl cation. Pivalyl cation. Decarboxylation takes place. Decarboxylation process. It loses CO. Remove CO group minus CO group. Then it gives CH3C, CH3CH3 plus. Why decarboxylation takes place? 3-degree carbocation is exceptionally stable. Exceptionally stable. 3-degree carbocation is exceptionally stable. That's the reason decarbonylation, remove CO group takes place. Now, electrophilic attack, benzene, attack electrophile, then it gives CH3, CH3, CH3. First option is correct option. Phenol is more acidic than benzoic acid. No doubt. Wrong. This is wrong. Why? Carboxylic acids are more acidic than phenol. In phenoxide ion, negative charge is delocalized over 1 oxygen and 3 carbon atoms. So it is more stable than benzoate ion. Wrong. This is also wrong. Both A and R are incorrect. Identify D in the following sequence. Okay, given ketone. Ketones are reacts with Grignard reagent. Further hydrolysis. Then it gives 3-degree alcohols. Then it gives CH3 OH, 3-degree alcohol. Alcohols are reacts with SOCl2. Then it gives haloalkane Cl. Haloalkanes reacts with KCN. Haloalkanes reacts with KCN. Then it gives cyanides. Now cyanides undergoes hydrolysis. Cyanide undergoes hydrolysis. Then it gives carboxylic acids. Then it gives carboxylic acid. What is the IUPAC name of the compound? IUPAC name of the compound: first carbon, second carbon, third carbon. 2,2 dimethyl Propanoic acid. Choose the correct statement choose the correct statement about the following sequence of reaction. 1,1 dichloroethane reacts with aqueous NaOH. Reacts with aqueous NaOH, two chlorine atoms are there. So take 2 moles of aqueous NaOH. Then it gives CH3CH, OH, OH, gemdiol, unstable. So further heating, then it gives aldehyde CH3CH double bond O. This is A, aldehyde. Aldehyde reacts with I2 plus NaOH. We know that acetaldehyde gives positive iodoform test. Acetaldehyde gives positive iodoform test and it is dissociated like HCOO Na plus CHI3. This is B. B is sodium formate, correct. B is treated with HCl followed by LiAlH4. H2O gives methanol. This is also correct. A is acetaldehyde. On treatment with NH2OH, A gives two products. Yes, because this is hydroxylamine. A carbonyl compound is easily reacts. How two products are possible? For example, you can take CH3CHO plus NH2OH. Remove water molecule, then CH3CH double bond NOH. Multiple bond present between carbon and nitrogen. It exhibits geometrical isomerism. Which type of geometrical isomerism? Syn and anti. C double bond C, C double bond N double bond N. Cycloalkanes are exhibits geometrical isomers. So based on that, two products are possible. Identify A and B in the following reaction. Okay. The first reaction, the compound is reacts with HBr. This is phenolic OH group. Phenolic OH group unaffected by HBr. This is alcohol group. Alcohol group is affected by HBr and it is converted to CH2Br. Phenolic OH group is as it is. Converted to CH2Br. After that, second, phenol OCH3. Yes, this is alkyl aryl ether. Break the bond. Oxygen gets negative charge. CH3 gets positive charge. H plus Br minus. Then it gives phenol OH. Fourth option correct. Correct order of reactivity of following compounds with CH3O minus in an SN2 reaction. Reactivity. So rate of SN2 is directly proportional to strength of the nucleophile. Strength of the nucleophile. Which strength is more? Bromine strength is more compared with fluorine and OH. So the correct answer is SO2. Name is triflate. Hydroxide. Given four structures, 1 and 3 are aromatic and 3 is more basic than 1. Correct only. 3 is more basic than 1 because here this is pyrrole able to donate pair of electrons left side as well as right side. More resonance is possible. Here able to donate pair of electrons only one side. One is anti-aromatic. No, wrong. Pyrrole is a aromatic substance. Basic strength order 1 less than 3 less than 2 less than 4. Correct. Conjugate acid of 3 is less stabilized than conjugate acid of 4. This is also correct. Correct answer is PRS. Basic. Because basic nature is directly proportional to number of nitrogen atoms. What is B? First step is diazotization. Diazotization gives BDC C6H5 N2Cl N2 plus Cl minus reacts with water, then it gives phenol. Statement 1, all monosaccharides are reducing sugars. Correct. D-glucose and L-glucose are enantiomers. Correct. Statement 1, statement 2, both are correct. The number of CH bonds that can involve in hyperconjugation in the major product X in the following reaction. What is the major product? CHF product is the major product. Remove hydrogen atom from carbon atom, beta carbon, which contains less number of hydrogens. Now, this is the C double bond C group. You can consider CH3. Here 3 hydrogen atoms, CH2. Here 2 hydrogen atoms, CH2. 2 hydrogen atoms. Number of alpha hydrogens with respect to C double bond C is equals to 7. Assertion: cis-1-chloropropene has higher boiling point than trans-1-chloropropene. Correct. Cis-1-chloropropene has higher dipole moment compared with trans-1-chloropropene. Correct. A and R are true. R is the correct explanation of A. How? Because higher boiling point is directly boiling point. Boiling point is a direct consequence of the stronger stronger molecular polarity or dipole moment. The hybridization of aluminum in the aluminum H2O taken 6 times plus 3. Aluminum is in plus 3 oxidation state. So 3s0, 3p0, 3d0. Water molecules uses first 6 empty orbitals. So S P3 D2 is the hybridization. sp3 D2 is the correct answer. AlCl3 is an electron deficient compound, but AlF3 is not because AlCl3 is a covalent compound, but AlF3 is a ionic compound. Based on this is completely based on Fuzan's rule. The correct increasing order of energy of the orbitals having following set of quantum numbers. Energy is calculated by using n plus L. So here n plus L value remains same. If n plus L value remains same, then energy is directly proportional to n value. So based on that, P less than R less than Q less than S. Choose the correct code containing correct statement out of given. A spectral line will not be seen for a transition 2px to 2py. Yes, this is correct. A spectral line will not be observed because 2px and 2py energies remains same. Energies remain same. That means these are degenerated orbitals. So spectral lines will not be seen. As the intensity of incident light increases, photocurrent increases. Correct. Velocity of electrons increases with decrease in principal quantum number. This is also correct. Vn is equals to velocity of nth orbit is equals to V by n. Energies of the orbitals in the same subshell decrease with increase in atomic number. Correct. How? As the atomic number increases, then nuclear charges also increases. Nuclear charges increases. That's the reason. So A, B, C, D are correct statements. Match the following. Most reactive metal. Most reactive metal is S block. Inner transition metal. Inner transition metal is F block. Most electron affinity element. Most electron affinity elements are halogens. Amphoteric metals. Amphoteric metals are present in 3A group. So based on that, the correct option is A4, B3, C1, second option. The correct increasing order of basic strength. Third one, Al2O3 less than, MgO less than, Na2O less than, CS2O. Groups top to bottom, basic nature increases, periods left to right, basic nature decreases. How many of the following have planar geometry? CCl4 undergoes sp3 hybridization with 0 lone pairs, tetrahedral geometry. SO3 undergoes sp2 hybridization, trigonal planar. SF4 is sp3d hybridization with 1 lone pair, geometry is seesaw. XEF4 sp3d2 hybridization with 2 lone pairs, geometry is square planar. BF3 undergoes sp2 hybridization, geometry is trigonal planar. C2H4 sp2 hybridization, this is also trigonal planar or planar. PCl5 sp3d hybridization with 0 lone pairs, trigonal bipyramidal. Here question is how many of the following compounds are planar? 1, 2, 3, 4. Which of the following the bond order has increased and magnetic behavior has changed? C2 plus total number of electrons 11 electrons, bond order value 1.5. C2 bond order value 12 electrons, bond order value 2. Magnetic nature diamagnetic to paramagnetic S changed. C2 plus paramagnetic nature to diamagnetic nature. Here question is only magnetic behavior changed. Dia to para or para to dia. NO minus total number of electrons 16 electrons, bond order value 2. NO plus total number of electrons 14 electrons, bond order value is equals to 3. 16 electrons even number, but it is paramagnetic due to presence of 2 unpaired electrons. N2 plus 13 electrons, bond order value 2.5. N2 14 electrons, bond order value is equals to 3. So all of these is the correct answer. If enthalpy of neutralization of CH3COOH with NaOH is minus 11.3 kilocalorie per mole, then enthalpy of ionization of CH3COOH is enthalpy of neutralization is equals to enthalpy of CH3COOH is weak acid. Weak acid plus strong base plus enthalpy of ionization. Enthalpy of neutralization value is given minus 11.3 and CH3COOH plus NaOH. Enthalpy value is fixed, that is minus 13.7 plus enthalpy of ionization. Now you can calculate enthalpy of ionization. Enthalpy of ionization is equals to 13.7 minus 11.3. You will get plus 2.4. Remember one point. Enthalpy of neutralization for strong electrolytes, that is maybe acid or base or acid and base, the value is fixed minus 13.7. In few books it is given as minus 13.6 also. Both are correct. If you can take minus 13.6 here, then you will get the exact answer 2.3. Statements given and find how many are incorrect. Solubility of sulfates of alkaline earth metals increases down the group. This is wrong statement. Not increases. Increases is wrong. Correct statement is decreases down the group. BeF2 is highly soluble in water. This is correct statement. Increasing order of bond angle H2O less than OF2 less than Cl2O. Wrong. The correct order is OF2 less than Cl2O based on the hybridization. Bond order of CO is 3 and bond order of CO plus is 2.5. This is also wrong statement. Bond order of CO is 3 but bond order of CO plus is not 2.5. Bond order of CO plus is 3.5. Remember, this is the exception condition. Xenon in XeF2 molecule is dsp2 hybridization. Wrong. It undergoes sp3d hybridization. So A, C, D, E. Fourth option correct. The correct statement is salicylic acid has intramolecular hydrogen bonding. This is the salicylic acid structure. OHCOOH. Yes, intramolecular hydrogen bonding is present. NH3 has high enthalpy of vaporization due to intermolecular hydrogen bonding. Correct. CuSO4.5H2O has ionic, covalent, covalent as well as hydrogen bond. Yes, correct. Ionic bond is present between Cu2 plus SO4 2 minus. You can dissociate like that, or it can be written as CuH2O taken 4 times SO4. Ionic bond is present. Beryllium is amphoteric metal and does not impact color to flame. This is correct. Beryllium is colorless, flame color. The S character of diamond. Diamond S character. Diamond undergoes sp3 hybridization. S character is 25%. Wrong. Graphite undergoes sp2 hybridization. S character is 33.33%. Acetylene undergoes sp hybridization. S character is 50%. So A, B, C, D are only correct statements. The heat liberated on complete combustion of 7.8 grams of benzene is 327. It is a combustion reaction. For combustion reaction, the value of delta H must be negative. Given positive, but you can take negative. First of all, how many number of moles of benzene is involved here? Here, mass of benzene is 7.8, molar mass of benzene is 78, number of moles is 0.1 mole. 0.1 mole of benzene liberates 327 kilojoules of energy. Then 1 mole of benzene liberates how many kilojoules of energy? 327 by 0.1, that is equals to 3270. This value is negative, minus 327. Why negative? Because it is a combustion reaction. For combustion reaction, the value of delta H is negative. Okay. Measured at constant volume. That means this is considered as internal energy. Delta U value is minus 3270. Then calculate delta H value. Okay, delta H is equals to delta U plus delta nRT. Combustion reaction, only consider gases reactant and gases products. Delta N value 6 minus 7 by 2. 6 minus 7 by 2. 7 by 2. 15 by 2. 6 minus 15 by 2, that is equals to minus 1.5. R value taken in terms of kilojoules, 8.314 into 10 power minus 3. Temperature you can taken in terms of kelvins, 300. Simplify, then you will get minus 3273.74 kilojoule per mole. So based on that, the correct answer is first option. Thank you.